Welcome to the second video in the Pinzgauer EV conversion series. In the first video, I went over the first stage of the EV conversion, how I ended up taking over the project, and the engineering challenges remaining. This video will go over how I tackled the first two major hurdles, which really prevented this truck from being usable. Those hurdles were, 1, a significant fluid leak, in this case ATF, and 2, a major vibration in the drivetrain that was literally enough to cause the motor to shake the bolts out of its mounts. Come check out this creative engineering project. I tackled the fluid leak first because, well, it was diagnosed first. The cause of the leak was actually discovered after the first full day of driving the truck home from picking it up. I had spent those 30 miles with very frequent stops to examine, wipe, add fluid, examine again, wipe, tighten things, whatever. I just couldn't find it. When we actually got to our mid-trip waypoint, a neighbor of my friend was curious about the truck, and I gave him a tour of the drivetrain. He was also a bit of a gearhead, and it was this random guy who spotted the leak. He noticed that there was this little dome protruding from the back of the motor hidden behind the front mount, and the fluid seemed to be coming from there. Digging into the online manual for the motor, we determined that the dome was actually a vent. That would seem to indicate that the motor was too full of ATF coming up above the vent line, but it didn't seem possible given how much experimentation I had done with fluid levels. More research into the coolant system design showed that my truck was delivered with a wet sump implementation and looked pretty close to what the motor manual shows, although after the filter and before the motor inlet, there was also an external reservoir. That does add an air brake into the system, but I think that should be okay. Anyway, as I stared at the manual, I noticed something. Note, motor must be oriented with sump at bottom. Yeah, this motor was mounted with the sump 45 degrees from the bottom, which put that vent too low. This was a great answer, but yeah, this wasn't easy to fix. Let's take a look. Alright, so my first project here is that I'm pretty sure that this motor is mounted rotated. This here is the sump, and this is the vent here, and the vent is leaking transmission fluid, which is the coolant in this case. So if we are to rotate this to the bottom, that'll bring the vent up, which I think should address that. And also, I believe that these hoses are reversed, so this is the one that they're pulling from, but since this is the sump, they really should be pulling from this hose. So we'll get that reversed. Now it's gonna be a bit of a pain because these are really short leads from the inverter, so I'm gonna have to make longer, because when we rotate this one's gonna, at least this one is gonna move far enough away that it's not gonna be able to reach. Yeah, and here's some footage of getting those leads taken off and of all the ATF everywhere. In addition to coming out of the vent, it was also coming out of the high voltage wire strain relief gland seals. I think with the sump too high, the vent too low, and the sump and inlet reversed, it just had fluid in all the wrong places and it found its way out. Somehow it seems to have even gotten into the inverter past the gland seals. I removed the motor leads and remounted the motor on the existing mount. I was just lucky that it had mount bolts every 45 degrees, so I could test this change without needing a new mount. Here we are from the bottom. Yeah, it rotated. You can see this thing is clocked every 45 degrees, and the sump is now perfectly at the bottom. Like, I don't know, maybe a few degrees off, but it's virtually perfect. And yeah, so now we'll be creating some new cables, swapping these lines for the for the automatic transmission fluid, ATF, and get on with life. Alright, problem 1 diagnosed. As for problem 2, the drivetrain vibration, this was just brutal, and I was really concerned I wouldn't be able to figure it out. Was it a motor software configuration problem, a mechanical problem? I just wasn't sure. We had tried a number of different motor software configurations, and they didn't seem to make much of a difference. The motor was always smooth with the driveshaft disconnected, and has resonance vibration modes with the driveshaft connected, even with the transfer case in neutral. So it kind of had to be something to do with the drive shaft, and so I learned as much as I could about this kind of drive shaft. This type of shaft, I learned, uses two single cardan joints. These are not constant velocity joints, and therefore susceptible to vibration if the cardan joints are not synchronized. Play at either end of the shaft obviously would cause a vibration. And finally, the larger the shaft angle, due to a large offset between the driving shaft and the driven shaft, would exacerbate any vibration. Now that we know how this shaft is supposed to work, time to spend some time under the truck. Right now, when I drive this thing, it shudders. And I believe it's because, or at least one contributing factor, is that this drive shaft is at a pretty intense angle. Well, I don't know, not super intense, but like it can be straighter. The Pinzgauer by default has an almost perfectly straight alignment for the drive shaft. These universal joints should be able to handle this angle, but like, I don't know. It's the car doesn't run that way normally, so maybe that's a problem. So anyway, in addition to rotating it, we'll raise it probably 2-3 inches, get this a lot straighter. So that's the goal. Here's another reason for some of the vibration, other than kind of the large offset in the angle here. The cardan joints are not in phase. So here we're straight up and down. And if you follow the shaft, here we've got some rotation. So we're gonna put these back in phase to get some of that vibration out. And finally, the smoking gun. So this spline adapter is not retained onto the motor shaft, meaning there's nothing holding it from sliding forward and backward on the motor shaft other than friction, really. The drive shaft is designed as two pieces that slide past each other, here. So it can dynamically change length to be able to deal with chassis flex, temperature changes, and to eliminate any force along the length of the shaft that is not rotational. So with whatever other vibrations or forces there are when this truck drives down the road, they're resulting in the spline adapter backing off the motor shaft. And you can see that even just with the strength in my arms, I'm able to slide it back and forth. Anyway, you can just imagine the racket of this turning at thousands of rotations per minute. Okay, so 3 changes to address this vibration. 1, we're going to raise the motor to reduce the shaft offset. This has the additional benefits of less wear on components, more ground clearance, and less loss in power transmission. We're going to synchronize the cardan joints properly, which is trivial. And 3, we're going to design a new spline adapter with a retainer of some kind. So 3 parts: front mount, rear mount, spline adapter. This is going to require CAD, 3D print prototyping, and a machine shop. Now, I'm not a mechanical engineer. I'm a hobbyist. But in my years of tinkering, I've developed a very basic familiarity with these tools. Plus, I had rough drafts of all 3 of these parts from the actual mechanical engineer who started this EV conversion, and he gave me his CAD files. So it's time to relearn modern CAD, figure out how to get parts 3D printed, and find a machine shop that can anodize and make splines. And we'll be going over all that in part 3 of this video series. So don't forget to like and subscribe if you want to join me as I finally get this baby spinning.